Problem 6. Water is flowing through a 30 centimeter diameter welded steel pipe of length 2,000 meters that drains a reservoir under a head of 40 meters. The pipe has a thickness of 8 mm. If the valve at the end of the pipe is closed in 10 seconds, approximately what water hammer pressure will be developed. Compute the stress of the pipe due to water hammer, the elongation of the pipe. If the steady state flow is instantaneously reduced to one-half its original value, what water hammer would you expect? Friction factor 0.02 and neglect minor losses. So if you write energy equation between water surface in the reservoir and the end of the pipe, then velocity head at the reservoir 0, pressure head 0, elevation head is 40, datum through the horizontal pipe. So 40 equals velocity head at the end of the pipe, pressure head 0, elevation head 0, plus head loss. So 40 therefore is velocity head plus head loss. Celerity is 2.07 for water times 10 to the 9 over density 1000, quantity 1 plus 2.07, 300 over 200 gigapascals for modulus elasticity of steel pipe, thickness of pipe wall 8 mm. So celerity is 1221 meters per second. Then again, 40 equals velocity head plus friction loss, 0.0826 friction factor length q square over diameter to the fifth. Replacing V by 4Q over pi 0.3 square and quantity square over 19.62 plus 0.0826.02 2000 over 0.3 to the 5. Combining, because they are like terms, so 40 equals 1369.87 q square because the minor losses are neglected. So there's no entrance loss coefficient. So Q is 0.1709 cubic meter per second. So the velocity is 4 times 0.1709 over pi 0.3 square. The velocity is 2.418 meters per second. So because the time of closure is 10 seconds, definitely this is slow closure. But we need to solve for pH first. C density V over 1000 to convert it to kilopascals. So 2952 kilopascals. Then by proportion, pH prime, so the pressure that will develop due to water hammer would be pH prime because the time of closure is 10 seconds. Definitely this is slow closure. So time for the pressure wave to travel round trip is 2L over celerity 3.276 seconds. And time of closure is 10 seconds, which is greater than this time. So it is slow closure. So pH prime as to 3.276, the smaller time equals 2952 as to 10 seconds. So pH prime, the pressure that will develop at the valve is 967 kilopascals due to slow closure. Then the second question, stress of the pipe due to water hammer. So this will develop a compressive stress which will stretch the pipe. So if this is the cross section of the pipe, this pH prime acts on the diameter inner area with radius 150 mm or 300 mm diameter, and the stress will develop perpendicular or normal to this material with outer radius 158 mm, 150 plus thickness, inner radius 150. So stress is force over area. The force is pH prime times pi 150 square. To convert it to megapascals, 0.967 megapascals, Newton per mm square. So the area must be in mm also. Then divided by area, which is pi outer radius 158 square minus 150 square. That's the area of this shaded part, annular area. We can cancel pi. So the unit would be megapascals because this is mm square, this is also mm square. So the stress in the pipe is 8.83 megapascals, and that is tensile stress. 6.3, the elongation of the pipe, force length over AE. Then take note, force over area is stress in the pipe, so it is stress length over E. So the length, let's convert that to mm. So stress 8.83 times 2000 meters times 1000 to convert that to mm divided by E of pipe, which is steel, is 200,000 megapascals. Megapascals 8.83 megapascals, so the unit is It 8.3 Then the last is if the steady state flow is instantaneously reduced to one half its original value. If the discharge is reduced to one half, so too the velocity is reduced to one half. And because this is instantaneous closure, so it is pH. V is 0.5 of 2.418, so 1.209. pH is celerity times 1000 times density of water times 1.209 velocity over 1000. So pH is 1476 kilopascals.